Hi, this is Harshit Sharma. Today I'm going to explain you about a prototype that we have made for Virtual Labs Hackathon 2026 happening at Dialbag Education Institute. So what we have made is a classroom thermal simulator. So what our simulator actually does it simulates real life uh, classroom conditions, how our temperature in a classroom changes, right? Taking in consideration different factors like the room dimensions, the number of people that we have in a room, the equipments that we have in a classroom, of course. So let me just go to you to all the variables that we have. Of course, first we have is the room dimension variable, the SVG that we have made for this. As you can see, the isometric classroom view. It is actually reactive as you increase the length or you increase the width of a classroom. As you can see, the SVG is also reactive to it. You can increase the height too. Actually, the room dimension is very important when you're taking in consideration the how the heat is going to exchange between the outside environment and the inside environment, of course. And for the same reason, we have number of windows and what are the window type we have, right? So, like we have double glass, double low E windows, tinted glass. So and of course number of windows and total window area. So why this is important? Because the sunlight is going to what we are assuming is that sunlight is going to fall at these windows, right? And these windows are actually going to also do the heat change, right? Because of the heat transfer outside from outside the classroom and inside the classroom. So this is the thing that we have taken in consideration. Of course, then we have taken in consideration the brick properties that we have, like what are the wall properties, because that is also very important when you're taking in consideration how temperature will rise inside of a classroom because of how the temperature outside is, right? Then we have number of occupancy that is also reactive. If you do this, you can see the number of student changing in a classroom, right? And then you can see heat per person, equipments that we have, number of lights we have. Because of course, these lights are also going to produce heat and thus increasing the temperature inside of a classroom, right? And then, of course, this is just the environment. For environment, what we have done is you can actually set yourself the solar intensity. Now, currently for the first simulation, I'm just going to put it at default, right? But you can of course increase that however a student wants to simulate, however the conditions that he wants, right? And then we have HVAC settings. So we are assuming that you can actually have zero HVAC in a classroom, or you can have one HVAC in the classroom. So what is going to do? It is actually going to simulate how thermal changes actually happen inside of a classroom, right? Like we have turned on the AC, how the temperature is going to change in how much time. Right, time is a very important factor we have here. So the capacity per AC we have used 1.5 ton. Of course, that is also changeable. And then we have ventilation fans, like normal fans we have, and then of course the electricity cost. That these are all the variables that you can change on yourself to understand, to visualize more how things will happen. So I'm just gonna do default features, right? In AC mode I'm gonna do, let's first start do always on, right? So always on is just going to take us see that the AC is always on, like it's never closing, right? And here you can see the HVAC cost price, right? And here is the total cost price. Total cost price, of course, including the fan, the lights we have put in the variables, right? So this is how after we starting from 28 degrees, the outside is this. Okay, the outside is this, right? Okay, let me just check. Outside is not changing, right? Outside is 35 degrees, and then inside finally we have this, right? So inside finally what we have is, okay, this is just inside finally we have 28.782. So why this is happening, why the temperature is actually increasing, is this is just only because the AC is very underperforming here, because it is very small. The classroom is very big. We have a lot of number of people in the classroom. Equipments there are very much, so it is actually increasing the uh, temperature rather than actually decreasing it, right? Then we have energy consumption. How energy is actually getting consumed from everything from, of course, the AC, the HVAC that we have used, then fans, light, and everything, right? Cost recognition, as you can see, uh, orange is for fan cost, right? And blue is actually for AC cost, and this dotted green line is actually for total cost, right? Of course, you can export these results right in a PDF format to actually understand how this actually works. Right, let me just show you that. Right, so of course you can see the total cost that we have, how for how much time that we have ran the simulation. Of course, that is very important. So the time actually depends. Uh, is going to change simulation a lot better. So let me just try to increase the time for 12 hours, and of course I'm going to increase the speed because we don't have that much time. So as you can see, now it is going to show us how temperature will change and how the cost will actually be if you ran an AC for 24 hours for 12 hours straight, sorry, right? So as you can see, okay, the temperature is actually increasing. It should decrease, and this actually shows us, it is actually going towards like the outside temperature. This actually shows us that our AC is very underperforming and under. How can I say that it's not enough. It's totally not enough for a big classroom like this. We need to change the AC as soon as possible to actually, if we want the results, like if we want target temperature to 24 degrees Celsius, we have to change the AC. And of course, it is going to take 160 rupees in a span of 12 hours. Right? Okay. So, of course, let me just tell you about how if we like increase the number of ACs, let's say we do four ACs, and the capacity per ton is 3 ton now. Right? And now let me just start the simulation. As you can see how the temperature is decreasing for 2 hours. This is for 2 hours. As you can see, the temperature will decrease at this point, right? This is at 24 degrees. Okay. Okay. Let me just check how this is. Okay. This is. It is actually at 84 around you can see at 77 minutes it is getting equal to the 24 the target temperature that we have, and later on decreasing. Finally, we got a temperature of 22.1105 for the same classroom that we are using, right? So this is the this is a normal classroom simulator when you actually keep the AC always on. But what we have made is actually we have added two more modes that we have made from ourselves. First is thermostat mode. Thermostat modes, it's simply, you know what it just does. Let me just tell you this how. Right. As you can see, as soon as the graph the temperature actually reaches towards the target temperature, the AC actually automatically gets off. Let me just show you in a bigger time span that you can understand it better, right? So keep on tracking of AC and the graph. Let me just do this. Okay. Okay, as you can see, as soon as the we got the temperature around 24 degrees, that is our target temperature, it actually we automatically make the AC switched off. So to save power cost and of course eventually save our cost on that, right? So after, as you can see, this is a type of graph that we got, right? It is actually why it is actually dipping like this, right? So we have explained this in our reference material that we have here, right? So what we have taken in consideration is of course compressor protection. Like when you start it, it actually takes some time to start, and when you close it, it actually takes some time to stop. Right, so we have taken that into consideration so that you don't burn out your compressor, right? And in a thermostat hysteresis, what we have taken is, when you see this, let me just go through that again, right? Let me, okay, see this. This is the point where it actually is going to, at around 113 minutes, it is actually going to increase the temperature again. It means it actually closes the AC. So why it does is at this is explained in this thermostat hysteresis. So what we have made is a dead band logic that we have used for all the HVACs that we have made is a temperature difference of 1 to 2 degrees Celsius. Like you have put the target temperature to 24 degrees Celsius, but it will not go to 24 degrees Celsius. It will go to 24 degrees Celsius plus 1 or 2 degrees Celsius upper or lower. so that to keep the AC more accurate, to make it more like real life. Okay. And then, of course, the other mode that we have other than thermostat is smart. Smart actually depends on the occupancy. Like currently, how many people we have? Currently, in a classroom, we have 35 people. But if, let's say, if we have zero people, we don't have anyone in the classroom, right? So what it does, it will not turn on the AC because we don't need to turn on the AC. We don't have anyone, right? It will just accumulate a cost of a fan and other equipments that we have in the classroom. So this is what we have made. Of course, we have pasted all the reference material, all the heat balances equation that we have used, right? We are taking into consideration the heat actually that is increasing because of the human. Humans also radiate some heat, right? The heat transfer from the wall, the solar heat gain, the equipment and lighting heat gain, ceiling and fan motor heat, air conditioning, how air conditioning works, and of course the energy cost and thermostat hysteria that I have already explained you, compressor protection and thermal mass. Thermal mass is just it just says that furniture holds 50 to 100 times more heat than air alone. A real classroom takes 30 to 60 minutes to cool, not seconds. So we have tried to make this as accurate as possible that we can. Right. Of course, there are a lot of improvements that we can do. Right. So this is the prototype that we have made. I hope you like this. If you have any other questions, you can ask in the comment sections, right? And of course, you can see and follow the GitHub link that I have pasted in the description. Thank you very much. I hope you are going to be good.